Like a Guru number 3. In Like a Guru 1 and 2, we discussed these data, international property prices from the Rob report, and I'm doing that again, as you'll see with the list I've already prepared. And the point about this is the filter worksheet. It says replace n/a with 99999. What's that all about? You'll see NA, many of them in fact. Because, as is the nature of these things, you go and get a raw database and there's bits missing. Nothing you can do about that, except I didn't want to delete the NA rows because I might go from 360 properties down to maybe 78, 80, 90, I don't know, I didn't do that. So what I decided was I would replace NA with 99999, and then you'll see how I dealt with that. So I don't lose any data, I don't lose any analysis. All right, well, you've seen the list of functions that I'm using in this Like a Guru number 3. The data are the same, international property prices from Brazil, Canada. Look at this, my data validation cell, Andorra, Bahamas, the same as in Like a Guru 2. With Spain, the most examples at 75, 78. All right, so what did I do? I used the filter function. Actually, I used the filter function. And look in the formula bar, filter. What this does, if you've never seen it before, this is why I put it under the heading of a guru. There's your ordinary everyday filter. All the way to there. So I'm filtering A6 to H365. That's the whole of this Rob report database. And what I'm doing then is with column F, the number of beds, I say, give me anything to do with beds less than 99999. And then G, the area, less than 99999. There are no properties anywhere near that size. I've checked. And then the same with baths, with H. In other words, getting rid of the NA problem. So there's my filter. But then I want to filter the entire table, including the headers. And the way to do that is to wrap around another filter. And this is based on what's in A4 to H4, which is these numbers here, 0 and 1. What that does for me, if we look at price, number 1 in row 4, if we look at beds, number 1, look at area, number 1, baths, number 1, the rest are all 0. If I choose 0 for the beds, it disappears. The column header disappears, and the data, the entire column for beds, disappears. That's the way that I control the number of columns. That's the first thing. That's my data set now for Canada. So that gives me the data. And with the data, I want to carry out my normal everyday analysis, which is to create a correlation matrix of these 4 variables. 1, 2, 3, 4. I didn't include the dollars per square foot. And I need to show that the price in dollars against beds has a correlation coefficient of 0.305. I know that now. Price area 0.7. That's a good relationship statistically. And price against baths is also quite highly correlated. Again, high. It's only that one. Beds, number of beds doesn't seem to influence the price at all. Now, how did I do that? Because it's dynamic. If I now choose France, for example, which has got about the same number of properties, it's recalculated the correlation matrix. If I go all the way down to Spain, which we know is the biggest one, again, all the data, and I've recalculated the correlation matrix. Now, how did that happen? So it's dynamic. Are you ready for this? In each of these cells is a let function. You can pause the video, and study this let function, but that's how to dynamically evaluate price, beds, and so on. Each of these is individual. With Spain, by the way, we saw for Canada, is it the same story? No. The price against beds for Spain is not bad, more than a half. 0.6, 0.6, 6, 9, and 0.7. These two are a little bit better. So different market, different profile. I then created the histogram for this derived column, and as you can see, the dollars per square foot for Spain follow that profile. Let's go back to Canada. Not so many, so we can't really compare the two. All right, there we are. Then moving on to regression analysis. So I'm using the LINEST function, and what I did here was I used IFERROR with a let function, using the rows function, index, sequence, and LINEST. Now, again, pause the video and take a look at this formula. And why did I use it? Why did I use the rows? What's index and sequence going to do with it? In order to set it up so that I can use the LINEST function, which is here. I wanted to use piecewise regression if necessary. What that means is, here I didn't label them, but here we are. This row isn't calculated as part of LINEST. All of these are. The B statistic, standard error, R squared, and so on. You do these manually by dividing the B statistic by its standard error, and we get T statistic of 0.27 for Canada. 0.82, 0.7, not very good. But because I did this for Spain, I'll put that back. When I ran the Spanish data through, I got a t-stat of 2 with an n of 70, whatever it is, 75, 78, 2, 3, and 0.65. That tells me that we know already from the correlation coefficient, well, I do the correlation coefficient because I'm expecting this now, that this is not so good. So I get rid of it. Piecewise eliminated. So I run the LINEST again without the beds, and now we get t-stats of 2.84, it's improved, 3.09, slightly better, and this should be a better model for us. Then over here, I use the let function to create the matrix of the y variable, which is the price, the prediction from whichever LINEST formula that one is, and the residuals. Which you would do is you do the regression and then you do the analysis by applying the regression, find the predictions, work on the residuals, and then do any further analysis, such as drawing graphs. And you can see here how I created it, and the same where that came from. Where do you get this file from? You go to my blog. I'll put a link below. You go to my blog, become a member of my blog, and you'll find that you have access to this Excel file there. Like a Guru, number 3, Between the Sheets, the original Between the Sheets. Thank you for watching.